Hello everyone, my name is Arjun Bhardwaj. This is the demonstration video of SIT210 Task 7.3D Raspberry Pi PWM. The objective of this task is to work with PWM on a Raspberry Pi and control functionality of a device, for example, a vibrating motor or an LED. For this task, I have to build an embedded device that detects if an object is approaching and notify using vibration motor, buzzer, or the brightness of an LED. The device will use ultrasonic sensor to detect if a solid object is approaching and alert the user. As the object gets closer to the device, the sound gets louder or higher pitch, or if using an LED, the LED would become brighter, or if using a vibration motor, the vibration will be higher. For this task, I am using an LED to detect the object. Now, coming to the hardware part of this task. So, for hardware part, we have to gather some components, including number one is Raspberry Pi. This is the central controller that runs the Python script to interface with the ultrasonic distance sensor HCSR04 and control the PWM LED. Then PWM LED, that is pulse width modulation LED, is used to control the brightness of the LED. PWM allows us to control the LED's brightness by rapidly turning it on and off. The longer the LED is on during each cycle, the brighter it appears. Then the ultrasonic distance sensor, this HCSR04, this sensor is used to measure the distance between the sensor and an object. It works based on the principle of sending ultrasonic sound waves and measuring the time it takes for the waves to bounce back after hitting an object. The Raspberry Pi interfaces with this sensor to measure distances. Now coming to the wiring connections. The PWM LED is connected to GPIO pin 30 on the Raspberry Pi. The ultrasonic distance sensor is connected as follows. Echo pin to GPIO pin 18 on the Raspberry Pi, trigger pin to GPIO pin 17, and VCC and ground pins are connected to the appropriate power and ground pins on the Raspberry Pi. Now, after giving the power supply, the Raspberry Pi is typically powered via a micro USB cable connected to a power source. Now, termination signal handling. The code includes signal handling for SIGTERM and SIGHUB. This allows the program to respond to termination signals, ensuring that resources are released properly when the program is terminated. I'll explain this in the software part too. So now coming to the software part for this task. So to complete this task, I have to import some necessary libraries. First one is sleep that allows us to introduce delays in the program. Then distance sensor that provides functions for interfacing with the ultrasonic distance sensor. Then PWM LED that allows to control of a PWM LED which can vary its brightness. So after this, I have created LED and distance sensor objects. LED represents the PWM LED connected to GPIO pin 30. Then distance sensor represents the ultrasonic distance sensor. It uses GPIO pin 18 echo to receive signals and GPIO pin 17, that is trigger, to send signals. Then I have defined the safe exit function, which is a exit safely. This function is called when termination signal, SIGTERM or SIGHUB are received. Then it exits the program. Now coming to the main function. The main function is where the core logic of the program resides. It continuously reads the distance from the ultrasonic sensor and adjusts the brightness of the LED accordingly. the LED is initially turned on, it calculates that brightness based on the distance. The closer an object is to the sensor, the brighter the LED. The brightness is constrained to be within the range of 0 to 1. The LED's brightness is set and the program sleeps for a short duration, that is zero point 0.1 seconds, before repeating the process. The program can be terminated by pressing Ctrl plus C, which is called by the keyboard interrupt exception. Finally, the sensor is closed to release the resources. Now coming to the execute the main function. This block ensures that the main function is executed when the script is run directly, not imported as a module. So the overall purpose of this code is to create an interactive system where the LED's brightness reflects the distance measured by the ultrasonic sensor. As objects move closer or farther away from the sensor, the LED brightness changes accordingly. This could be useful in various applications, such as proximity detection or creating visual indicators based on distance. Thank you so much for watching the video.